Hello everyone. Today we will discuss research methodology. Research conducted for the purpose of contributing towards science by the systematic collection, interpretation, and evaluation of data, and that too in a planned manner, is called scientific research. This scientific research is supposed to be scientific, systematic, and verified. We will discuss a little bit more about the characteristics of scientific research. So, these are the predominant characteristics of scientific research: empirical observation, replicable experiments, provisional results, objective approach, systematic observation, purposiveness, testability, rigor, parsimony, generalizability, falsifiability. So, these are all various characteristics attributed to scientific research. Okay, now we already discussed the characteristics of scientific research. Now, our next topic is objectives of research. So, basically, scientific research, the objective of the scientific research is to achieve new insights and also to develop new theories. If you have a hypothesis with sufficient evidence gathered to support the hypothesis, you can develop new theories. And again, if you generalize such theories, then you can develop new principles. Again, of course, you can determine the relationship between two variables. In normal forms of the research, you can determine the relationship between two variables, or find the relation between any two factors, something like that. So, the relation between height and laziness, for example, a question: if you want to find out whether laziness is directly related with the increase in weight, then the only possibility is that to analyze, to gather some data related with the people's, classify the population into different groups, like those who are lazy and not lazy. Two groups should be considered, and then collect the gather the data with their weight information and related information is to be gathered. Then compare these two categories and see whether the lazy people were gaining more weight during the test period. So that means easily you can determine, using scientific methodology, you can determine the relationship between such variables. Now, when we discuss about the variables, the next category is the type of variables. So the next topic that you want to discuss. Variables in research are usually, there are constants and variables are there. Constants were usually fixed numbers like 2, 4, 6, or they are actually constant. They won't vary throughout the experiment. Whereas a variable may be marked as x, y, z, which can assume any value. So such type of variables were of three different categories, and the first one is a independent variable, and second one is a dependent variable, and there are some extraneous variables like temperature, illness, emotional state, etc. Or they are also known as confounding variables, which will affect the original variables. That is, independent and dependent variables. The independent variables were actually, they are independent of the test. So test results and test conditions, whereas dependent variables depend on the independent variables. The input that is given as the independent variable, for example, say you are considering the sleep deprivation as an independent variable, so that can vary. Okay, the test performance, or the overall quality of the sleep can be determined. So the test performance, or any test performance, like sleep deprivation, can be considered as an independent variable in a study group of students. So if the students were not getting enough sleep, then usually their test performance or their exam performance may be affected due to sleep deprivation. Consider such a hypothesis. And in that case, the sleep deprivation is an independent variable. So it is not affected by anything else. Maybe, of course, there are extraneous variables like temperature, illness, emotional state, etc. May confound, or they may affect the original sleep deprivation. Still, if you are excluding that extraneous variables that affect the sleep deprivation can be considered as an independent variable, which will have an influence on the test performance. So the test performance depends on sleep deprivation and similar other factors. And such type of variables were known as dependent variables. So dependent variables were affected by various other factors, whereas independent variables were not such factors. That can be considered as many factors under the study under consideration. For example, you can consider the relationship between many factors x, y, and z, and that variables, independent variables, needs to be studied, and the data needs to be gathered, and they will have an effect on the test performance, like sleep deprivation or an enzyme activity in case of a biological system. For example, nutrient composition, pH, temperature, etc. can be considered as independent variables, which will have a direct effect on biomass production, and the biomass production is a dependent variable in that case. So the next one is the overall research methodology. So the methodology, which may be of various types, where we will perceive a question, usually to ensure the question is scientific or empirical, and that's an important part. So the research question or that you want to answer, or the hypothesis from which this question, or the question from which the hypothesis is generated, and that question needs to be scientific. So you have to ensure that the question is scientific, and there should be empirical or experimental methods that is available to verify that question. Okay, so that's what the first step. Then you need to, if you have a question in your mind to address, then you can formulate a hypothesis based on the question. In one of the previous sessions, we discussed that based on the available literature and other things, we should have an induction, and that induction is actually the step of perceiving the question. So there are some questions that needs to be addressed, that will be generated based on the existing data, and to solve the question, once it is induced, you will generate a hypothesis, or you will formulate a hypothesis that can be verified later. So the third step is the testing of the hypothesis. And during the testing of the hypothesis, we already discussed in detail different types of hypotheses and its biases, etc. So confirmation bias of the hypothesis is one point that needs to be addressed, because for a researcher, for every researcher, there should be a bias towards their hypothesis. If you propose a hypothesis, for example, the sleep deprivation, you believe, or you are proposing that, or you are hypothesizing that sleep deprivation directly affects exam performance, then you are trying to gather all the evidences in support of your idea, and the other ones which will be against or which will refute your original findings will be rejected or ignored. And that type of confirmation bias is normally observed, which needs to be avoided in scientific research. So you have to collect all the data, whether it is positive or negative, then you need to test a hypothesis. And if you are gathering only the evidences in favor of your work, then that is not a scientific way, because any evidence coming up against that hypothesis needs to be considered. So that that's the original concept of the falsifiability. If you ignore some of the evidences, then we cannot say that it's a scientific way. Then you have to draw a conclusion. So you have a research question, you based on which you formulate a hypothesis, then you test the hypothesis using some methodology, and again you from the results of the testing, you will draw a conclusion, and that conclusion should support the goal of your prediction. What you are going to predict, that needs to be supported. If the hypothesis is valid, then it will be supported by the data, and report the results, and should be able to replicate the results. So once you report the results, anyone who is testing this hypothesis under their own conditions, under their own laboratory conditions, with the same set of environment variables, then they should replicate the result. And as we discussed in one of the previous slides, replicability is one of the key characteristics of scientific research. So such type of results needs to be reproducible under other set of conditions, other laboratories or by others under the same experimental conditions. So this is a slide which shows the flow chart of the research progress. It is already discussed in one of the previous sessions. So here you can see that there is once again I am explaining. You have to define a research problem where we generate a question, and that question generate problem is actually is the induction stage in which we review various concepts and theories and previous research findings or literature review. And using this literature review, you generate a question, search question that needs to be addressed, and based on which you formulate a hypothesis. And there should be a research design or a methodology that facilitates the testing of the hypothesis. Then you collect the data, analyze the data, test the hypothesis, and again redesign the experiment if it is necessary. And finally, you enter the results and report. So that's the normal procedure for the research methodology. And we already discussed the null hypothesis, usually in science we are actually proposing null hypothesis because we say that there is no significant difference between the test and control. For example, the sleep deprivation doesn't have any effect on test performance. That is null hypothesis. And if after testing, if you find a significant correlation between sleep deprivation and exam performance, then you can reject the null hypothesis. So that's how normal hypotheses work. Now, types of research and data collection is another area in which we need experimentation and observation. Experimentation is one method of data collection. So experimentation, which include placebo effect, then experimental effect, then single blind or participant unaware experimentation, double blind experimentation which participant and experimenter are unaware. So there are different types of experimentation methods. Placebo effect is actually a placebo. It's not actually a drug. It is a placebo which is not a drug, but it is given in the pretension of in the disguise of a drug. So the patient or to whom it is administering, he will be thinking that it is a drug, but it is only a placebo, and it will have its own effects. Maybe for a test and control, for example, to one population you can administer the actual drug, and another group you can administer placebo, and then compare two groups. Whether the placebo is imitating the same response as that of the experimental drug, then certainly you cannot support the drug, because the same effect is actually done by the placebo, which is not at all a drug, which is a simple enough compound. Okay, and that type of placebo effect needs to be addressed while testing such experimental conditions. And another one is experimental effect. Experimental effect means the experimenter will have his own styles and some methodologies, or he may affect or change the methodology in some way or other. So from person to person, when we are performing the experiment, certainly there will be some differences in the results. And that type of experimental effect or the experimentation style of the experimenter that may affect the results. That is one of the categories that is affecting the experimentation. And there is another category that is a single blind experiment. Single blind experiment means a participant is unaware of the experimentation. So if participant is unaware of the actual experimentation, then that is a single blind one. And in double blind one, for example, you are giving one patient placebo and another one, say, a drug A and another one a drug B, and the patients or the participants of the study actually they were unaware of which one got which one. So that's a participant blind or participant unaware single blind approach where you don't know. For example, you are administering you are administered with a COVID vaccine Covaxin and another one is with the Covishield, and actually the participant doesn't know which vaccine is administered, but the doctor or the surveyor actually or the experimenter knows which patient is administered with which vaccine. So in that case, the effect of the patient is or their interpretation is not applicable in that case. So even double-blind methods were also there. Like experimenter is also unaware. For example, the sample will be labeled as A, B, or C, something like that, and the experimenter will administer it into the participants. And only those who are analyzing the data will know that which one is administered with which drug. So that type of double-blind experimentation in which participant and experimenter unaware condition, that's also possible, so that it will eliminate many placebo effects, experimenter effects, and such other influencing factors in the experimentation can be minimized by single blind and double blind approaches. So the second category of data collection is based on observation, and it can be arranged either in naturalistic environment or in laboratory environments. In naturalistic environments or naturalistic settings, there are some factors that affects the observation, and like observer bias is one of the important factors, and it is quite necessary to eliminate observer bias towards the experiment. So observer should be neutral while collecting the data, and usually a one-way mirror technique is used so that the presence of the observer is hidden from the participants, so that the observer is behind a one-way mirror, so that the participants were not aware of the presence of such an observer who is observing the experiment. Now, another method is participant observation. Participant observation means one of the participants or the observer is included in the study as a participant itself. So the other participants were unaware of the presence of such an observer as a participant in the group. Then blind observation is also another category, and in that case nobody knows who is the observer and who is the participant, and so that the data can be collected from any point, so that that's a type of blind observation in which the participants, some of the participants may act as an observer for other group, and vice versa also, that is possible. So that type of observation is a blind observation. Now, it is something similar to the blind experimentation that is described earlier. And in case studies, and of course, there is another category like laboratory-based, or instead of naturalistic environment, you can arrange such observation in laboratory settings. For example, say the observation or behavioral studies that is done in mice in the physiology laboratory, for example. That's one example of a laboratory experimentation with observation. Okay. And another case, another category is a case study. Case studies are studies, or it's a study of everything about a single person. So usually papers or scientific articles were published as case studies. So everything with related with all the scientific aspects related with a single person or a single patient is reported as a case study. And post facto or study after the event, that is another category in which the uh, event in question has already occurred. Usually, when we are designing an experiment, what happens is that we design the experiment, when we perform, then we perform the experiment, and the result will be obtained in a later stage. After designing and performing the experiment, the result is obtained. So you have a provision for obtaining the result, desired result of the experiment later. But in ex post facto research, or in such type of a study, the event has already occurred. So based on which you analyze the data, or you collect the data from an already occurred event. And in that case, it is a post facto, ex post facto. That means the event is already occurred, and we study the event, or we collect the data from the event at a later stage. So it is not a designed experiment, but it's only only data collection and analysis of an already occurred event. So that's another category of data collection. Now another category is survey. Survey, actually, they not intrude into personal matters. They should not intrude into personal matters. And randomization is also possible in surveys. Usually, there are a lot of studies based on surveys, especially in library science, or in humanities, wherever such a questionnaire-based data collection is nowadays very popular. Even in internet platforms also, that type of surveys are there. And usually the surveys should be designed in such a manner that it should not intrude the personal affairs or personal matters while conducting the survey. And some amount of randomization is also required, because survey should not be biased. You know that there are a lot of surveys about the election results, for example, pre-poll surveys and post-poll surveys, etc. And if the surveyor, or the personal interest of the surveyor, or the sponsor of the survey, if they decide, certainly they can influence the results. And in that case, it should be scientific. And you should have noticed that many of the surveys, or the channels, TV channels who conducted the survey, they say that their methodology is so scientific, their sample size is sufficient, and they performed a sufficient amount of randomization, and all other parameters were true. So their result is accurate. They may claim something like that. So if something happens, like if there is some bias on the observations or interpretations, or if they collect samples from some areas only without proper randomization and other things, then the survey or the quality of the survey will be affected. Usually surveys were conducted based on interviews and questionnaires. Now, another one is a projective test, which is another category of data collection. The projective test is actually a type of psychological test in which the personality of a person, or an individual, will be assessed based on, and usually the individual will respond to some ambiguous scenes or words or images, and accordingly, person to person, their response will vary. So that type of based on their personality and psychological conditions, the response will be different, and that type of tests were actually known as projective tests. Now, coming to the sampling in research, there are simple random sampling, systematic random sampling, and cluster sampling. So, in simple random sampling, you can randomly select samples from different locations, and that type of random sampling, randomized simple sampling, is there. And another one, for example, from the entire population, say you have 100 students in the group, and you can pick any 10 of them. Just by random sampling, you can pick any of them and take an opinion poll, especially for example on election results or something, or something else. You can perform any survey on that particular group of 10 people selected from 100. So that's a type of simple random sampling. But a systematic random sampling that may divide this group of 100 into different. For example, say in the election results, you might have noticed that they will divide them into male and female. They will divide them into different age groups. They will divide them into different, say, caste-based groups or religion-based groups, etc., etc. So each group, representation of each group will be ensured while sampling. For example, the samples will be designed in such a way that the 10 samples will have 5 males and 5 females, and there will be at least say one or two from age group less than 25, two from age group 25 to 50, and another two from 25 to 50 to 75, something like that. So the sample can be grouped, or the entire population can be grouped as a separate entities, and then samples can be again randomized within the group, so that representation of every population will be represented there. So especially when you are conducting such election pre-polls and surveys, etc., that is very much required. If you collect the samples from younger population or teenagers or youth, then you will get one result. If you collect the entire samples from old age people, you will get another result. If you collect the entire samples or most of the samples from women, then you will get another result. So the representative sample from all the clusters is required, and that type of all the groups is required, and that type of sampling is a systematic random sampling. And then cluster sampling is another one, in which different types of clusters. For example, you sample from Kasaragod, you sample from Trivandrum or different localities, and such type of different clusters will be analyzed, and so that the entire overall, or if you think about nationwide or Lok Sabha elections, etc., then each cluster or statewide clusters that can be considered. Each state will have its own criteria and its own election patterns, so that will be different. So the results that is obtained from Kerala will not be applicable in Tamil Nadu, because that's another cluster with another set of conditions. Such type of, to get the overall idea of the sampling, you require such a cluster sampling. So simple random sampling, systematic random sampling, and cluster sampling, etc., were different sampling methods that is used for collecting the data. Now another topic is on research ethics. So research ethics is most important in scientific research. So usually the policy should be such a way that the participant first and experience second, and the privacy and safety and security of the participant is of prime importance, and the experiment is not that much important when you consider the safety, security, and privacy of the participant. So experiment always comes second, participant first. And it should be confidential. All the works related to data collection and experimentation procedure needs to be kept confidential. So there should be a confidentiality agreement signed between the participant and the researcher. Then the participation should be voluntary. Voluntary means you need to sign a consent form, an informed consent form, so that the participant is voluntarily participating in the study. So that type of, especially in medical and other patient-related studies, you require an informed consent from the participant, and which ensures the voluntary participation, informed participation of the participant. So there a format of informed consent, voluntary informed consent of the participant. That form needs to be signed. So in that case, the experimenter or the doctor, whoever conducting the experiment, needs to inform the participant about the test and its side effects, if any, its advantages, if any, and everything needs to be explained to the participant before including that participant in the group. So, which requires voluntary participation, or which demands voluntary participation with the informed consent of the participant. Then also you need to debrief after study. So after the study, the patient or the participant needs to be debriefed about the overall study and the outcome and other things. So that needs to be the participant needs to be debriefed after the study, so that the effect or impact of the study should not last longer and should not affect the participant's psychology or emotional state. Now, participants can withdraw at any point. There should be a provision. It is the right of the participant to withdraw from the study at any point. You can't compel the participant to continue with the work, and it is at it's completely at his will. He is participating in the study, and it doesn't mean that once he signs the agreement and or once the willingness or the informed consent form, he is bound to continue with the study. At any point, he can exit. That right is that should remain with the participant. Also, you have to ensure no harm to the participants. If any adverse effects or side effects, then it is a duty of the, for example, if it's a drug trial, the company's responsibility to treat, and all the expenses should be met from the company's account. Then debrief invigilators, that is also required. And after finally, even the doctors or the participants or the scientists or the observers who is participating in the study, they also need to be debriefed. And if there is an undecided outcome, you can detect or remove and ensure the participant's comfort. So, if there is any undecided outcome, you can, if it is detected, then you can remove the participant from the study, and also you can ensure the comfort of the participant in whichever way that is possible. So these are all part of the research ethics that is followed, or that should be followed. And the next one is on data analysis. So in data analysis, we have various tests, statistical tests like t-test, f-test, chi-square test, then kurtosis, skewness, etc. These are all some of the terms. Kurtosis is the peak of the graph, that is, or that is kurtosis. And skewness is, say, this is a positive skew. This is a symmetrical distribution. This is a negative skew. So on to which side these spreading is shown. So in this case, if in case of a positive skew, the mean will be on the right side of the median, and whereas in the negative skewness, it will be on the left side of the mean will be on the left side of the median. Okay, so this is some of the patterns of the graph, and kurtosis is actually this is a peak of the graph. And this is the normal, this is negative kurtosis, this is a positive kurtosis. So if the peak is above the normal, then it is a positive kurtosis. So these are some of the terms, and these t-test and f-test are chi-square test, etc. are the most common test that is used for analyzing the data. And the RSM is another type of data analysis, that is a response surface methodology, which is used for designing the experiments, and we'll discuss it later if it is required. So RSM is a response surface methodology, which is a statistical method for designing the experiments and studying the combination effects of multiple factors. So if you want to study the best interacting factors out of a group of 10 different factors, then the best effective interaction among 10 different factors may be determined based on a limited number of tests or trial runs, and that design of the experiment is done by the response surface methodology, so which is also known as a design of experiments method. So these are some of the data analysis techniques that is used. And these are some of the possible graph patterns that can be used in your research. There are histograms, pie charts, then bar graphs with the standard errors and other things, line graphs. So various types of there are a lot of different packages, so statistical packages, which can be used for plotting the graphs, and you can use any one of them according to your requirement. So there are a lot of graph patterns that can be created, and contour plots, etc., were used in case of RSM, surface plots and contour plots. So anything can be, any type of graph can be incorporated in your paper after the analysis of the results. So then we come to the last stage, where thesis writing. And after thesis writing, that's one of the important aspect, where you summarize your results and present it as an abstract, as a paper or a thesis. So the thesis should have a title, an abstract, a review, the methodology, then results, discussion, references, and appendix. So this is a normal format of a thesis, in which there should be a title. The title should be self-explanatory, and especially if you are writing a paper, then that should be very unique and striking, so that the rejection, the first stage rejection of the paper is actually dependent on the quality of the title. So if you can design such a title that very well explains within a sentence, if it explains your original work, the original concept of the work, then that title will be the appropriate one. Then there should be an abstract, which will be limited to, say, a few words, or a few hundred words or something. And within that word limit, you have to give a brief idea of your objective, then the methodology that you followed, then the results and the original findings. So that needs to be presented in the abstracts. Then there should be a review, and the review of the paper or the thesis is actually the literature that you reviewed to reach the to generate the research in question or the hypothesis, or for the induction of that question, what are the references that you reviewed, that needs to be presented in the review part. Then the methodology. The methodology should be scientific, and you can't randomly alter the methodology. It should be a standard protocol, and so that nobody will challenge it. So an accepted standard protocols needs to be incorporated in the methodology, and with proper references. That methodology should not be questioned by others, because if you alter the methodology and if it is under challenge, then the entire work will be doomed. So it should not be done. So methodology should be scientific, and that scientific methodology, commonly accepted, widely used methodology, needs to be adopted, rather than depending on some individual experiments, which is rarely used. So you can use commonly used well-known methodology. Then the results. The results need to be presented in the form of tables, graphs, etc. And if it is required, statistical analysis needs to be done. And then graphical representation will be better if you are presenting a thesis. Then that needs to be done. Then finally, the discussion. The discussion should be basically it should be usually when we are writing the thesis, the order should be the reverse. You can review can be created at any time. Methodology is also during the performance of the experiment also you can write the methodology. But once you have the results, you have to write the discussion. So, and after analyzing the result, you will interpret it and you write the discussion. And after concluding that discussion, you, based on this analysis, you have a very clear-cut idea of the original work, and whether the purpose of the work or the objective of the work is justified or not. That is very clear after you write the discussion. The abstract actually it needs to be written at last, because it is the original or the actual summary of the work. Okay, abstract that needs to be written at the final stage. So the discussion, it should be a proper interpretation of the results, and explanations should be provided based on the available references in the discussion. So that while writing the discussion, your original research question or the hypothesis need to be kept in mind. Whether you are addressing that research question while discussing, that is the most important factor. So that needs to be done. Then you can use the appropriate references at the end, and referencing will be another session that we'll discuss in one of the forthcoming classes. So referencing with such computer programs like bibliography management softwares like say Endnote or Zotero or Mendeley, like that of various bibliography management softwares are there, and that can be used for automating the references, and different formats of references and other things will be discussed in the later sessions. So referencing is the final stage, and proper referencing is most important in science, because if your reference is of poor quality, your paper will not be accepted in the journals, because while you submit the article, the journals will have their own format of referencing, and automatically the computer will recognize the reference whether it is a valid one or not. So if it is not, then certainly the reviewer will reject it. So that type of proper referencing with a correct style needs to be followed while writing the thesis and research papers. And finally, if there is any other items or raw data that needs to be added as an appendix, that can also be added to the thesis. So this is a common format of writing a thesis. Okay. Thank you.